Good afternoon, students. So, we are studying about force in our chapter, force chapter 2. So, yesterday we have studied about the different means topic, like the topic is rest. So, what we define rest? Rest when an object does not change its position with respect to its surrounding, then it is called as rest. Yes. Then the next topic we have studied about the motions, or if we say simply, motion means movement of object. Movement of object. So, motions when a body changes its positions with respect to its fixed point or the surrounding with a time is called as motion. Then after we have deal with the word called speed. So, what is speed? Speed, what we say that is the when an object changes its positions with respect to the surrounding, or we can say that is the accelerations of the body or change while changing the positions. That's speeds we have studied. So, the unit of speed is meter per second. We have that one also we have studied yesterday, and we also deal with the average speeds. So, average speeds means what? That is the average when there is means the when an object cover a particular distance with a different means accelerations or the means velocity or speed, sorry. Like for example, when it travels 3 meter per second with a velocity of 3 meter per second, or we can say that 6 meter per second, then 3 meter per second, at that time 1 second, first second, second second and third second. So, at that time how we will calculate the speeds, average speeds, in which we have I have shown you the equations also, that one d1 when it travel 3 meter in 1 second, 6 meter in 1 second, 3 meter in 1 second, then how we calculate the speed? Speed is calculated by adding d1 plus d2 plus d3 upon t1 plus t2 plus t3. That is, in this way we calculate. So, first second 1 plus 1 plus 1 and 3 plus 6 plus 3, that creates average speed. So, speed is was distance covered in a particular time. So, today we will go to the another topic we call as the velocity. So, velocity is just similar to the speed, but what the difference is? Speeds only have magnitude, isn't it? Speeds only have magnitude, whereas velocity has directions also. Therefore, we say that displacement upon time taken, or rate of change of displacement with time in respect to the time or unit time, then it is called as the velocity. So, velocity how we define? It is the rate of change of displacement is called as velocity. Okay. Then now let us say what are the difference between speeds and velocities. Speed and velocity. What is the difference between them? The first one is that it is the change in positions with respect to time. Okay, you can write in different way. I am writing this one so that you can easily understand what I want to say you. That means it changes the positions with respect to time. and it is the change in positions in a particular directions with respect with time. Sorry, with respect, we don't need this one, with time. So what is the difference we have seen? Speeds only focus on the distance travel. Okay, it does not show any directions where the object is been moving, whereas the velocity is the change in positions with respect to the direction. It also say that where the object is been moving, in east side or west side or south side, or it is traveling from Butol to Kathmandu, or it is traveling from Butol to Pokhara, etc. in which route, straight line. So it show the directions with time. So it only show what? Magnitude. Okay, that therefore it is a scalar quantity. It show only magnitude, it does not show direction. Therefore speed is what? That is the scalar quantity. And velocity show both magnitude and directions. Therefore what it is? It is a vector quantity. Vector quantity. So speed is the what? Change in positions with time. It is change in positions with the directions, in particular directions in time. It is scalar quantity and it is vector quantity, and both are been what? Both units are what? Meter per second. Don't be confused that it is meter per second. And what is the numerical formula for this? Numerical formula, speed, numerical formula, yes, that is distance, speed, distance travel upon time taken. Whereas velocity is what? That is the displacement upon time taken. Okay. So in this way there is a difference between speeds and velocity. So I think you have got the idea about what is speeds and what is velocity. They are, although they have the similar units, but the difference is what? This is scalar quantity, velocity is the vector quantity. It show only magnitude, it show only the positions where it is changed with time, and it show both the means magnitude and directions, means positions along with the directions of the change with time. So these are the difference between speeds and velocity. Now comes to the next one, is the what is average velocity. So what is average velocity? Average, we know that mean, isn't it? Or are you sure? That is what is average velocity? Average velocity, if the body, or we can say that vehicles or whatever, the moving object, if a body move with uniform velocity or uniform acceleration, when a body move with uniform acceleration, there will be change in the initial and final velocity. So before going to the average velocity, I should point out what is acceleration means, what is initial velocity and what is final velocity. Now first to come to the word acceleration. What is acceleration? That is the rate of change of velocity. Okay, acceleration is rate of change of velocity. That is what we can say, that is the change in the velocity with respect to time or with time. Okay, like for example, an object is moving from point A to point B. Point A to point B, suppose it is start from rest. Start from rest means what? The initial velocity. The first, initial means the first and final means the ending velocity. Okay, in a simple word we can catch about that one, that initial means the first, previous means the first one, and final means the last one. So the initial velocity, if it is 0, okay, if the initial velocity is 0 meter per second, because the object is in rest, and when it travels to a time t, suppose with a time t second, it reaches 20 meter per second. Suppose an object move or the vehicle move from point A to point B. Previously at point A it was in rest, then after that it start to move to the point B and attain 20 meter per second at time t second. Then what is acceleration now? Suppose the t time may be 5 seconds. So how we calculate the speed? That is rate of change of velocity, means the final velocity minus rate of change. Change means what? Subtracting initial velocity upon time is there, we are calculating with respect to time. Therefore, that is acceleration means rate of change of velocity. That is the rate of change of velocity. How we calculate? The final velocity minus initial velocity with time. That means 20 minus 0 upon 5. That means we are not writing unit, only to describe what it means. So rate of change of velocity means that is the difference between the two velocity, the first velocity and the end velocity with respect to the time is called as acceleration. So what we are saying, that if the body moves with a uniform acceleration means it is moving with accelerating means in a same way, increasing its speed to in the same way. At that time we can calculate average velocity. Okay, average velocity, how it is been calculated? It is been calculated when if the object is moving with a uniform acceleration, then only we can calculate the average speeds. Okay, otherwise it will be difficult. So in our chapter we are totally dealing with the uniform acceleration or uniform velocity. Okay. Now average velocity equals to what? V plus u upon 2. Average means mean value. How we will calculate the mean value? Mean means what? You have studied in maths also. Means if there are two values, mean equals to x1 plus x2 upon 2. Like that, I think so you have studied the mean and median and mode. Okay, like average velocity equals to v plus u upon 2. So what is v then? What is v? V is denoted by final velocity, is denoted by the symbol v. Okay, and initial, What I say initial velocity? Yes, good. Initial velocity means u, that is the first velocity and the ending velocity. So, we divide the final velocity with the initial velocity, then the average velocity can be calculated. So, do you understand the topic? I think so. We will continue the next topic, accelerations. So, before teaching the average velocity, I have already said that what is acceleration. It is the, what is acceleration? What is acceleration? What I said? Acceleration means rate of change in velocity. I will not say your rate of change in velocity, I will say rate of increase in velocity. So, why I am saying this one, rate of increase in velocity, rate of increase in velocity. Why I am saying this, that one? What may be the reason? Yes, because acceleration means increasing the velocity, not decreasing the velocity. Okay. Suppose a body moved from point A to point B, then with the time taken it increases value. If it increased like 2 meter or 2 meter per second, 3 meter per second or 8 meter per second with a second, first second, second and third second. With third second it reached to the velocity of 8 meter per second, suppose increase the rate of it, increase with the uniform way, okay, uniformly. So, rate of increase in velocity is called as acceleration. So, how it is been calculated then? Acceleration equals to, you have studied in your definition that rate of change in velocity is acceleration. So, I am means not writing the change in, why I am not writing, you will understand later on. So, rate of increase in velocity means, that is how it is been calculated. It has been calculated v minus u upon t. What is v? Just now we have written. Yes, good. That is the final velocity and u is the initial velocity, and acceleration is denoted by small a. Okay, acceleration is denoted by a small a, and its SI unit is meter per second is there, or we can say that meter per second minus meter per second upon second. So, what happened? Meter per second square. So, that is the unit, SI unit of acceleration is meter per second square. Now, you will heard the another word, that is retardations. Actually, in most of the means book, it is directly written rate of change of velocity is acceleration, but the negative acceleration is denoted by retardations. Now, I will give the example also how it will work. Now, retardations means negative accelerations. Now, what the negative acceleration means? For example, accelerations. Suppose from point A to point B, and a vehicle is moving, a bus is moving from point A to point B. At point A, it was in rest and it moved and reached a velocity of 8 meter per second, suppose. We are assuming that one. Okay. we are considering that one, that the object was in rest and it is moving to the point B with 8 meter per second with a velocity of 8 meter per second at a particular time. That means the velocity, initial velocity was 0 meter per second. So, the velocity is increase or decrease. You can see from the unit also, it is increase or decrease. Obviously, it is increase because initial velocity was when there is in rest, this is 0, and when it reached to the final point, then its velocity is 8 meter. So, that means that the initial velocity is less than the final velocity. It means that the velocity is increasing. At that time, that is what we call as the acceleration. But what happened? A body is point A, the body is moving with a velocity of 8 meter per second, moving, okay, not in rest. We remember that point, not in rest. It is moving, continuously moving. But what happened? Before the point B it reached, before it reached to the point B, all of sudden some of the object come in front of the road. Suppose a boy is standing on the road, then what the driver have to do? He will apply a brake. He will apply a brake, then after some time it move, what happened? The vehicle come to rest, isn't it? After the brake is applied, it may stop at the same time or means same distance, or it moves a bit and it is stopped. So, at that time what happened? What will be the final velocity when it's come into the rest? The final velocity will be 0. Now, u is 8 and v is 0. So, the velocity increase or decrease? What happened? That is, the velocity is decrease. Therefore, or we can say from the means formula also, t, v is how much? V is 0 and it is 8 meter per second with time. So, it is what? Minus 8 meter per second upon time. That means that the velocity is decrease, and if the velocity decrease, it is also acceleration, but what? That is the negative acceleration. At that time, what we call as, that is the retardations. That means the rate of increase in velocity is acceleration and rate of decrease in velocity is retardation. So, combinedly what we have studied in class 8, that is the rate of change in velocity is acceleration. We are silent about the retardation, but we have to do the numerical of retardations also. Therefore, I make you clear that that is retardations means decrease in velocity, whereas acceleration means increase in velocity with time. So, till here you are clear? Yes, I think so. You are clear about that one. So, again the another word will come, that is the uniform means acceleration. So, what is uniform accelerations? Uniform acceleration. What is uniform acceleration then? Uniform, I already tell you about this one before also. Uniform means equal. Uniform means equal. When a velocity changes equally in equal interval of time, means it travels or it means increasing with equal intervals of time, then it is called as the uniform accelerations. Equally increasing with equal time, that is called as, suppose 1 second 1 meter per second, 2 second 2 meter per second. It is just an example. Okay, it is just an example, you should remember. So third second, then it is increased to 3, means it is uniformly increasing by how much? 1 meter per second. So in these types of accelerations, we say that that is the uniform acceleration. So how we define uniform acceleration? That is what? That is the increasing of velocity or equal increasing in velocity in equal interval of times. Okay. Now we will go to the main part, that is the equations of motion. Okay. In our chapter, we are studying about equation of motion. So what are the equations of motions are there in our chapter, or what are the equations of for the uniform motion? For the uniform motions, we will derive 3 equations. The first one is the V equals to U plus AT, the first equation. The second equation is S equals to UT plus half AT square. Okay. The third equation is V square equals to U square plus 2AS. So these are the 3 equations of the uniform motions. Now I think in class 8 you have studied about Subhat. Subhat in short form. Now what is Subhat then? In short form we say that Subhat, so that there are 5 units are been there. What is as? Displacement or the distance. Mostly it is written as distance cover. Okay. That is what? As, it is denoted by as. Then initial, we have already written initial velocity, that is U. Final velocity V. Then acceleration of an object, accelerations is denoted by A, and time taken is denoted by T. So in this way we denote the in equations of motions, we use a 5 unit, that is the displacement, initial velocity, final velocity, accelerations and time taken. So this is the first equation. So let us go to the first equations. V equals to U plus AT. Suppose point A and point B, in a straight line an object is moving. Okay, an object is moving in a straight line. An object, or we can say that the bus is moving, it is in the state of rest or initial velocity, where an object velocity, initial velocity is U meter per second, initial velocity is U meter per second, final velocity is V meter per second. Suppose I am writing the unit so that it will make you easier to know what U and V denotes. By seeing the unit we can verify that one. So the distance covered between them is S and the time taken to reach that one is T. Okay. and the accelerations produced when it moves from one is a. Okay, is a. So, in this way, by seeing this figure, we can derive three of the equations of the motions. So, let us suppose there is distance is not that. Suppose a bus is moving from point A to point B. While moving from point A to point B, its accelerations is a meter per second square. It reached to the accelerations means having a accelerations meter square, and it takes, while reaching the point B, it takes t second. Okay. So, let us consider a vehicle or object moving with a initial velocity of u meter per second and having an acceleration and accelerations of a meter per second square, having an accelerations of a meter per second square, and in time t second it's have a final velocity of v meter per second, then we have what we have? We have what? A equals to v minus u upon t. Yes, that formula we have, that is the acceleration of the body is v minus u upon t. Then we will cross multiply that one. Suppose if there is nothing written, then we say that the denominator will be 1. Then a t then a upon this v minus t. Okay, a t equals to v minus u, and if we take v equals to u plus a t, then therefore we can write also v equals to u plus a t. So, the first equations is proved. We will continue this one tomorrow. So, thank you to all of you, all the students, those who are watching, and I hope you got something to study from this, and you can derive these equations so that it will make you easy for tomorrow. Thank you to all of you.